Find the equivalent annual amount, A. In this problem, a present value payment, P, was made on an investment. After 4 years, the investment will be sold for its book value, BV4. We'll compute the book value by assuming the asset depreciates according to the double declining balance method, where the total lifespan of the asset equals 10 years. The problem also states the interest rate is 2.75% and continuously compounding. To find the equivalent annual amount, A, we'll add the amount initially invested in the asset times the appropriate discount factor to the book value times a second discount factor. The problem states the initial investment, P, equals negative $40,000. For the two discount factors, R equals 2.75% and the variable N equals 4, because the annual amount, A, will be calculated over the span of 4 years. Keep in mind, this value for N of 4 years is different from the total lifespan of the investment, which is 10 years. This value of 10 years will be used to compute depreciation. Next, we'll compute the two discount factors for continuous compounding. After plugging in 0.0275 for R and 4 for N, the first discount factor equals 0.2678. The second discount factor is computed by plugging in the same values for R and N, and this factor equals 0.2398. At this point, the last variable we need to compute the equivalent annual amount, A, is the book value, BV4. The book value is the value an asset can be sold for at year J, which equals the initial book value minus the depreciation for all years 1 through J. The book value at the beginning of the first year equals negative P, which is positive $40,000. Using the double declining balance method of depreciation, the depreciation during year J equals 2 times the book value at the end of the previous year, all divided by ND. In this equation, we want to use 10 in the denominator and not 4, because 10 refers to the lifespan of the asset. If we plug in 1 for J and $40,000 for BV0, the depreciation in the first year equals $8,000. This makes the book value at the end of the first year equal to $32,000. Next, we'll compute the depreciation in the second year, D2, by plugging in the book value at the end of the first year and 10 for ND, and the depreciation in the second year equals $6,400. This makes the book value at the end of the second year equal to $25,600. The depreciation during year 3 equals 2 times $25,600 divided by 10, which equals $5,120. And the book value at the end of the third year equals $20,480. And lastly, the depreciation during the fourth year, D4, equals $4,096. Now we can compute the book value at the end of the fourth year, which equals $16,384. Now we can return back to our original equation for A. Plug in the values of P, BV4, and the two discount factors, and the annual amount, A, equals negative $6,783. When reviewing the possible solutions, the answer is C.